The average annual cost of electricity used in retail buildings in the United States is $1.21 per square foot. For a box retail store, electricity costs can exceed $250,000 per year. In many climates, air conditioning accounts for 25 to 50% of these costs, largely because the need for cooling coincides with peak electrical demand, when electricity costs may be at a premium. Although newer variable speed air conditioners can reduce annual electricity consumption by 50%, they do not provide much savings during peak electrical demand. This is because the hotter it gets outside, the harder the air conditioner's compressor has to work to cool the air. Once the temperature gets high enough, even high-efficiency vapor compression systems provide minimal gains over standard equipment. This is not true for evaporative cooling technologies. They improve their efficiency as the outdoor air temperature rises, reducing both overall energy consumption and peak electrical demand. Numerous modern evaporative technologies have proven effective through third-party testing, and customers are reaping the energy savings they deliver. One such third-party testing facility is the UC Davis Western Cooling Efficiency Center, or WCEC, the makers of this video. The WCEC researches, develops, and demonstrates technologies, including evaporative cooling technologies, that address both overall energy consumption and peak demand. A variety of evaporative cooling strategies exist for commercial buildings, and they can be categorized into two broad groups: condenser air pre-coolers and ventilation air coolers. This video will explain one evaporative cooling product called DualCool, which combines both strategies. DualCool is designed as a retrofit for existing commercial rooftop air conditioners. DualCool uses evaporative cooling in two different ways, hence the name DualCool. Number one, it improves the efficiency of the vapor compression cycle, and two, it reduces the ventilation cooling load. Let's explain that a little further. An air conditioner cools air inside a building by blowing air across a cold coil that contains a refrigerant. When ventilation is required, air from outside is mixed in with air being recirculated within the building. The heat from the air is transferred to the refrigerant. A compressor pumps the refrigerant to another component inside the air conditioner, called the condenser, where the heat collected from the building is exhausted, or rejected, outdoors. In short, an air conditioner moves heat from inside the building to outside the building. The hotter it gets outside, the harder the compressor has to work to reject the heat. When this happens, the compressor uses more electricity and the performance of the air conditioner is reduced. One of the ways DualCool saves energy is by cooling the air around the condenser, making it easier to reject the heat to the outside. DualCool cools the air around the condenser by pumping water over a rigid evaporative media. As the warm outdoor air passes through the media, the heat of the airstream evaporates the water into the air, cooling both the air and water exiting the media. The chilled air then arrives at the condenser coil, allowing the air conditioner to operate more efficiently, as if the outdoor temperature were lower. In the process, DualCool also generates cold water. This water circulates through a water-to-air heat exchanger, located in the ventilation airstream, which cools ventilation air before it enters the rooftop unit. The water is then returned to the evaporative media on the condenser side of the DualCool. In this way, DualCool simultaneously reduces the cooling load and improves the efficiency of the vapor compression cycle. Although evaporation is used to provide these benefits, no humidity is added to the air that then enters the building. The evaporated water is rejected outdoors by the condenser fan. DualCool is effective for a range of climates and applications, but the energy savings achieved increases as outdoor temperature increases and humidity decreases. So, DualCool is particularly well suited for hot, dry climates. Most of the western United States is suitable for DualCool. The manufacturer, Integrated Comfort Incorporated, or ICI, conducts detailed site surveys to confirm that each potential site is a good candidate for their product. Independent laboratory and field evaluations of DualCool have confirmed that it can reduce electricity use by 40% during hours of peak electrical demand. Of course, total energy savings depends on the specific conditions in which the technology is applied. As with any efficient cooling strategy, greater savings are possible in buildings with larger cooling loads and longer operating schedules. Whereas some efficient cooling strategies are designed to replace rooftop air conditioners, DualCool is designed to retrofit or add on to existing systems. As long as the existing systems are in relatively good condition, DualCool can reduce energy use by harnessing the power of evaporative cooling, and equipment replacement is unnecessary. DualCool customers include several large stores with locations in California, Nevada, Utah, Arizona, New Mexico, and Texas. As of 2017, roughly 1,800 DualCool units were installed and operating throughout the western U.S., with over 700 units in California alone. Like any HVAC equipment, DualCool requires ongoing maintenance to ensure it continues to function reliably. As an assurance, the manufacturer provides proactive seasonal maintenance for every DualCool system for 5 years. Maintenance is simple but important and usually includes 3 site visits per year: a spring startup visit, a midsummer check to make sure the unit is working properly, and a fall shutdown visit to prepare the unit for the off-season. As with any new technology, it is important to have a foundation of service professionals that are familiar with maintenance and system operations when problems inevitably arise. DualCool maintains a network of trained technicians throughout California and the western U.S. These professionals make regularly scheduled service calls and are available if problems arise. Energy efficiency can sometimes seem like a black box. Ambitious claims of energy savings are promised, but it can be difficult to know how well a technology is actually performing. DualCool includes a web-based dashboard where customers can view HVAC system performance in real time. The tool can be set to send custom notifications and includes analytic features that allow for the measurement of energy savings. The DualCool dashboard provides transparency into how well the technology is working. Evaporative cooling technologies of today are designed to minimize water use and deal with a range of water supplies with varying quality. The money saved from reduced electricity consumption and peak demand can be used to offset the cost of the water used, which is typically only 3 to 15% of the electricity savings. The cost of a DualCool installation varies with the project details, including the number and size of the units. The manufacturer estimates that a retail space that operates 16 hours a day, 7 days a week, might reasonably expect to recover the project costs in about 5 years. Expected payback periods decrease as projects increase in size, since there are economies of scale for larger systems and more units. Utility incentives may also reduce the cost to the customer and expected payback period. Of course, actual payback will vary in each circumstance, but customers who have installed the DualCool report payback periods within 5 years. DualCool is sold directly to customers through the manufacturer, Integrated Comfort, and select distributors. Initial sales inquiries can be made through their website, www.icidualcool.com/sales/. DualCool units are built in Integrated Comfort's warehouse in Sacramento, California, and installed by affiliated technicians who receive in-depth training from the manufacturer. Technicians are convened each year to share the best practices and learn about any modifications to the product. Integrated Comfort maintains a close relationship with their approved technicians, so customers can trust that installers are reputable and experienced.